Nurul and Azira 118212. So today, we are from Group 13. We present to you guys about runaway chemical reaction and vapor cloud explosion which occurred at Synthron Reactor. This incident occurred at Synthron, North Carolina on 31st January 2006. The company manufactures coating and paint additive by polymerization in a 1,500 gallon reactor. The company had received an order for slightly more of an additive than the normal size receipt would produce. So the problem begins with the plant managers scaled up the recipe to produce the required larger amount of polymer and added all of the additional monomer needed into the initial charge to the reactor. This doubled or more the rate of energy in the reactor, exceeding the cooling capacity of the reactor condenser and causing a runaway reaction. So what is runaway reaction? The reactor pressure increased rapidly. Solvent vapors was released from the reactor's manway, forming a flammable cloud inside the building. The vapors found an ignition source, and the resulting explosion killed 1 worker and 14 injured. The blast destroyed the facility and damaged site of structure. The U.S. Chemical Safety Board (CSB) found that the reactor lacked basic safeguards to prevent, detect, and mitigate runaway reaction, and that essential safety management practices were not in place.
Assalamualaikum, I'm Salis. Now let's understand further about the reactor that's involved in this incident. The reactor is a 1,500 gallon equivalent to 5,678 liters semi-batch reactor by Folder Company. And as we've learned before, semi-batch reactor is similar like batch reactor. Only in semi-batch reactor, there is reactant addition or product removal in progress of time of the mixing. And the semi-batch reactor is equipped with an external jacket dedicated to heating, cooling, an anchor stirrer, and also a reflux condenser at the top of the reactor. The condenser is to ensure that the vapor that's produced from the reaction is not released to the surrounding. The standard plant recipe for the polymerization scheduled the following steps. Firstly, loading the reactor with cyclohexane, toluene, and N-butyl acrylate. Secondly, heating the reactor to desired temperature. Thirdly, add small amount of initiator solution. Fourth, waiting for the triggering reaction to be reduced. And lastly, number 5, adding slowly monomer and more initiator solution. As you can see, the chemicals that are involved are highly flammable, such as toluene and cyclohexane. And that's all from me. Let's hear from Asyiqin.
Alright, thank you, Salis. Okay, now it's my turn. Detective Nur Asyiqin binti Kamarudin. Just kidding, I'm Nur Asyiqin binti Kamarudin. So, I will talking about what problem occur. So, look at this batch right there, okay? Right. So, here's the problem. This batch actually 12% material more than usual. So, a senior operator actually firstly heard a hissing sound and saw a vapor coming out from the manway, kind of like inlet from the reactor. Other employees were forced to come out from the building as soon as possible, and the same operator, senior operator, re-entered the building by wearing respiratory to make emergency water cooling flow to the reactor jacket. Boom! The building exploded. Right after 30 seconds, the senior operator came out from the building. Okay, and here's the video of after the incident happened. Okay, so here's how sad the accident. Okay, so here's my opinion. Okay, I think it is because the vapor release why the accident happened. Right. He agree with me. Okay, he agree with me. So the inlet, the manway, I mean the reactor manway usually use only 4 of 18 okay, 18 clamps specified by the manufacturer as their usual batch recipe reactor, but this is unusual and more material, so they are supposed to use more clamps or use all of the 18 clamps, right? Okay, that's all for me. Thank you.
Okay, so now I'm going to continue to the solution part of the Synthron reactor incident. So the alternative solution that the company have taken after the incident is they file for bankruptcy and the facility has never been rebuilt again. On the other hand, the proposed solution that the company should take to prevent this kind of accident from happening is first thing first, they have to train their chemists properly, or they should hire a competent chemist. This is because a competent chemist can maintain a high degree of awareness towards the hazard material that they are working with when performing a reactive reaction. For instance, a competent chemist should ask what can go wrong before performing the recipe changes. However, the Synthron decided to just go with the recipe changes, and this actually shows that they are lacking of corporate oversight of process safety. Other than the chemist itself, all personnel inside the Synthron actually should be trained with emergency evacuation procedure. This is because CSB has concluded that Synthron was not prepared for any emergency. They doesn't even equip with emergency alarm system. Okay, that's all. Thank you.
As in my recommendation part, generally the company's management should consider to equip the factory with automatic emergency cooling flow so that it will shut off the initiator feed, which can prevent the effect of lost control over the reaction. The incident happened because the workers couldn't manually activate the cooling system. Next, the condenser should undergo maintenance routine. Rust, scale and sediment on the surface greatly degraded the capability of condenser by at least 25%. Furthermore, the cooling water was not changed and cleaned for 30 years of its services, which tell us why the emergency mechanisms not efficiently worked. Lessons to the upcoming reactors handler or worker from the incident are: first, follow SOP correctly. Each and every standard operation procedure or SOP must be obeyed as a precaution step. Please mind that it is created to protect your life and property. Number 2, less is more. Do not ever jump in changing the procedures purposely just to increase the production. If the reactor requires change, further discussions and R&D must be due. Number 3, knowledge, experience and awareness. Every worker in a facility is compelled to prepare themselves with knowledge of their work field and fully understand the safety, as it will increase the awareness of reactions hazards. That's all from our side. Till then, thank you and bye.